Welcome to the first part of the Mathematical Proofs lecture series. So, the first thing we will look at in these mathematical proofs lectures is some fundamentals, and the first fundamental we will start with is sets. So what is a set? A set is a collection of objects. And objects in a set are called elements. So, some examples. This is how a set is normally written. We open some brackets and close them. So this is a set A with the elements 1, 2, and 3. Or similarly, we could have letters inside a set. So this is a set B with elements A, B, C. Another example could be cars on a lot. Just draw a car here. Should give some neat little pictures to go with these lecture series. So say you have a car, and then you have a truck. So if you were to describe the cars on this lot, you would have car, car, and truck. Or another example of a set could be fruits. So let's say you had get some different colors here. Say you had a fruit bowl, and maybe you would have an apple, get another color here. Maybe you might have some bananas. Or maybe you might have some grapes. So if we were to describe this set, we would have apple, banana, grapes. Try to make this lowercase to help distinct between the letters identifying sets and the ones identifying elements. So another thing about sets, sets can have elements as sets or possess a condition or property. So some examples of something like this. Say we have a set S and these are the elements A, R, D, and then we have the element AD. This is a set inside a set. That's an element. And then for a given condition or property, say we have a set R with a variable X with the condition X minus 4 equals 0. Well, if we were to rewrite this set, we could rewrite it as R equals 4. Because the solution to this set where X minus 4 equals 0, X would have to be equal to 4. Now, we have some special sets. So these special sets, they are used often, so they are given special notation. Try to make that a little clearer. So, one such thing is natural numbers. So the natural numbers will be, draw this fancy looking in, and I'll explain that kind of writing font here in a second. So natural numbers are 1, 2, 3, and so on and so forth up to infinity. So this type of writing font is called blackboard bold. Because if you were to look in most textbooks, you would see that they would have a bold, trying to make that look bold, in to represent natural numbers, and the same will be said for these other special sets that we'll look over. But to make things simpler, we'll just write it with a little additional line or slash through it, just to make writing easier. So that we have the natural numbers, and we have integers. So this will be a z. And for sets, these 3 dots right here often describe that there's an implication that can be made or understood from the pattern that's observed in the set. So it's just it's negative infinity to -2, -1, 0, 1, 2, so on and so forth. Those are the integers. We have rationals. This will be represented by a fancy blackboard bold Q. And this is defined by m over n, where m and n are integers and n is not equal to 0. And then we have irrationals. This is represented by I, and this is where x is not equal to m over n, where m and n are integers, and n cannot equal 0. Then we have real numbers. It's represented by an R. Where R is a rational and an irrational number. So basically the real numbers is all the rational and irrational numbers. Then we also have complex numbers. And this will be represented by C. It's in the form A plus BI, where A and B are real numbers, and I equals square root of -1. Okay, so that is it for the short description of sets. Now we will move on to a property of sets, and we'll change colors here since we're looking at some different topics. So now we will look at cardinality. So cardinality describes the number of elements in a set. And the notation to describe cardinality is two solid lines with whatever set inside these two lines. So, an example. If we are given a set A is then the cardinality of set A would be 4 because we have 1, 2, 3, 4 elements inside set A. If a set has a cardinality equal to n, where n is a non-negative integer, the set is finite. Otherwise, the set is infinite. Okay, so that is it for cardinality. So now we will change and look at another topic of sets, and that will be subsets. If every element of a set belongs to another set, then the set is called a subset. A notation that describes a subset is an underlined sideways looking C. So, for example, for sets A equals and set B equals A is a subset of B, because the elements of B and F of set A are also in the set B. Sometimes subsets are analyzed by a specified set U called the universal set. Subsets can have intervals too. They can have an open interval where X is an element of the universal set and A is less than X, which is less than B. Or they can have a closed interval The difference between an open and closed interval is we use parentheses for an open interval and brackets for a closed interval. And this is defined as x is an element of the universal set, where a is less than or equal to x, is less than or equal to b. Or they could be half open or half closed. So for example, for this half open set, it's defined by x as an element of the universal set, where a is less than or equal to x, which is less than b. One more thing about subsets is a set is a proper subset if it is a subset but not equal to the set. And the notation for this is similar to subsets, but there's no underline for the symbol. So, an example. If we have the set A is 1 and 3, and set B is 1, 2, and 3, then A is a proper subset of B. All right, this is the last topic that will be looked at for this video, and that is going to be power sets. So, a power set is a set that describes all the subsets of a given set. The notation is a fancy font P with whatever set inside the parentheses. So, here's an example. If we're given the set A is 1, 2, 5, then the power set of A is the empty set. One, two, 5. Then we have 1, 2, 1, 5, 2, 5, and then so an important thing to remember about power sets is that the empty set will always be an element, and that all the elements besides the empty set and the power set will be described as sets, because going back to the definition, describes all the subsets of a given set. So, the cardinality of power sets is defined as equals to n, where n is the number of elements in a given set. So for A is a set with elements 1, 2, 5, same set we had from the previous example. The cardinality of the power set of A would be equal to 2, 3, because we have 1, 2, 3 elements, 8 elements. And if we go back up here to the example, we can count 1, 2, 3, 4, 5, 6, 7, 8 elements in the power set. So that is it for this first part of section 1.